Welcome to this demo showcasing the intent-based network border protection solution developed for FLUIDOS. This solution was designed to address the dynamic and evolving nature of workflows within FLUIDOS, where the network perimeter must remain secure, even as the environment scales and shifts across multiple clusters and administrative domains. In today's increasingly complex infrastructure, securing workloads is critical to protect all parties involved. This means isolating the provider from the hosted services and the consumer from the hosting infrastructure. Equally important is empowering the user to precisely define the network communication rules they need, supporting key security principles like zero trust and least privilege. As part of the FLUIDOS European project, we have developed an intent-based solution to automate network isolation and configuration across a seamless, borderless continuum. The solution follows two key phases: verification and harmonization. The first phase, verification, checks the received flavors to ensure that their associated network authorizations are compatible with the network intents defined by the consumer. The second phase, harmonization, occurs automatically within the provider's cluster. It ensures alignment between the consumer's requested network intents and the provider's network authorizations, translating these into Kubernetes network policies to establish the secure network boundary once resources are deployed. By the end of this process, only the communications explicitly requested by the consumer are allowed, in strict adherence to the least privilege principle. Let's walk through the scenario presented in this demo. On the left, we have the consumer who wants to offload some resources and needs to restrict communications to a specific set of interactions. These could be directed either to other resources within the same remote cluster or through a secure internet connection. On the right, the provider offers 4 different flavors, each with a distinct network authorization set. Ultimately, the third flavor is the one that aligns with the consumer's network requirements and is selected for resource allocation. Let's dive into the demo itself. We begin by setting up both clusters. On the provider side, we will also update the flavors to reflect the 4 distinct network authorization sets we mentioned earlier. As you can see, the provider now has 4 flavors, each associated with a unique set of network authorization intents. Let's take a closer look at one of them to see how this information is integrated into the flavor definition, particularly under the network authorization section in the properties. Next, we apply the solver on the consumer side to initiate the resource acquisition process. The solver quickly resolves the request, and you'll notice that the list of peering candidates is populated with the 4 flavors from the provider. The first critical phase, verification, is performed on the consumer side to check which peering candidate is compatible with the consumer's requested network intents. Let's review the log of the Secure Border Controller, where we can see that all the peering candidates have been evaluated, and the third candidate is the one that meets the consumer's requirements. Once identified, we proceed with the resource acquisition by correctly filling in the reservation and allocation custom resources. After deployment, the peering is established, and we can confirm this with the lictal command. The final key phase is harmonization. Before we proceed, we need to update the contract on the provider side, adding a reference to a shared config map that will hold the consumer's network intents. By running this script, We offload the consumer's resources onto the provider while simultaneously populating the shared config map with the requested network intents. Once this process is complete, let's check the provider's secure border controller logs. Here, you'll get insight into the harmonization process, where we see how the network intents have been translated into Kubernetes network policies. These policies are then applied to the provider's cluster, creating the secure network perimeter as we've seen throughout the demo. And that's the end of this demo. We've demonstrated how FLUIDOS' intent-based network border protection solution automates and streamlines the process of securing dynamic workflows, allowing providers and consumers to work together securely, while respecting security principles like zero trust and least privilege. Thank you for your attention.